Good morning, sir. My name is Hemlata. I am from Computer Science and Engineering Department. My topic is self-referral structures and unions. Topic: self-referral structures and unions. Outline: Introduction to self-referral structures, understanding unions, how self-referral structures work, applications of self-referral structures, advantages of using unions, implementing self-referral structures, limitations of self-referral structures, limitations of unions, conclusion and future directions. Introduction to self-referral structures. Self-referral structures are data types that allow for recursive relationships within the same type. These structures are commonly used in linked lists, trees, and graphs to represent hierarchical or interconnected data. Understanding self-referral structures is fundamental in computer science for efficient data organization and manipulation. Understanding unions. Unions are a data type that enables storing different data types in the same memory space. They are particularly useful in scenarios where a variable can hold multiple times but only in one at a time. Unions save memory space and enhance performance by reducing data footprint in applications. How self-referral structures work. Self-referral structures utilize pointers to reference other instances of the same data structure. This allows for building complex data relationships such as node pointing to its child nodes in a tree. The recursive nature of these structures can lead to elegant algorithms for traversing and manipulating the data. Applications of self-referral structures. Self-referral structures are widely used in implementing dynamic data structures like linked lists. They are also essential in representing hierarchical data such as organizational charts or file systems. Understanding these structures is critical for developing algorithms in such trees or graphs traversal. Advantages of using unions. Unions provide a flexible way to manage memory by allowing multiple data types to share the same space. They can lead to more efficient code as the programmer can choose the most appropriate type for each situation. Utilizing unions can also simplify the data structure by reducing the number of variables needed. Implementing self-referral structures. To implement self-referral structures, you typically define a struct or class that contains a pointer to itself. For example, a node in a linked list contains a pointer to the next node in the list. Care must be taken to handle the base case appropriately to avoid infinite loops during traversal. Understanding union implementation. Unions are declared in a manner similar to structures, but only one member can be added to at a time. The size of a union is determined by the size of its largest member, optimizing memory uses. Accessing members of an union requires careful management to ensure that the correct type is used. Limitations of self-referral structures. One limitation of self-referral structures is the potential for memory leaks if not managed properly. Recursive structures can also lead to stack overflow errors if the depth of the recursion is too great. Debugging can be more complex due to the interdependent nature of the data elements. Limitations of unions. Unions can lead to type safety issues as the programmer must ensure the correct member is accessed. Mismanagement of unions can result in undefined behavior, particularly if data types are incompatible. Unions provide no built-in mechanism for tracking which members is correctly active, complicating uses. Conclusion and future directions. Self-reference structures and unions are powerful tools in programming and data management. Continued advancements in programming languages may enhance the functionality and safety of these structures. Understanding and mastering these concepts is essential for any aspiring software developer or computer scientist. Thank you.